All right, so we are looking at question 13 from section 13.4e, the exercises from the book, which is looking at tangent plane equations at a given surface at a given point. And so our question here is xy plus yz plus zx equals 11 at the point P, which is 1, 2, 3. So the first step is to rearrange this equation in terms of z. So to do that, we're going to factor out a z from the x, z, and zx terms. So this is going to become xy plus z times the quantity of y plus x equals 11. Then we're going to subtract over the xy and divide by the y plus x in the same step here. And we're going to get z equals 11 minus xy over y plus x. And that is our equation just rewritten in terms of z. The next step here is to find our partial derivatives. So the first partial with respect to x is going to be the derivative with respect to x of the top of that equation there, 11 minus xy, times just the bottom, y plus x, minus just the top, times the derivative with respect to x of the bottom, all over y plus x squared. So the derivative of 11 minus xy is going to be negative y, and the derivative of y plus x is going to be 1. So to save some time, I'm just going to write this as negative x squared plus 11 over y plus x squared. And there's our first partial with respect to x. Then the first partial with respect to y. Let's give ourselves some more space here. Is going to be a similar formula. The derivative with respect to y this time of the top times the bottom minus the top times the derivative with respect to y of the bottom, all over y plus x squared. And the derivative of 11 minus xy with respect to y is going to be negative x, and the derivative of y plus x with respect to y is going to be 1. So again, to save some time, I'm just going to write this as negative y squared. This should be y up here, and this should be an x squared plus 11 over y plus x squared. All right, this is our first partial with respect to y. And so now we're just going to do some quick calculations of things we'll need in the future step. So we're going to take our point here, which is x1, y1, z1, which is 1, 2, 3. And we're just going to evaluate. We're going to need f of 1, 2. We're going to need f sub x of 1, 2. And we're going to need f sub y of 1, 2. So f of 1, 2 is going to be 11 minus 2 times 1 over 2 plus 1. This is going to be 9 over 3, or 3. F sub x of 1, 2 is going to be negative 2 squared plus 11 over 2 plus 1 squared. That's going to be 4 plus 11 is 15 over 3 squared is 9. So that's going to be negative 15 over 9, which is negative 5/3. And lastly, f sub y of 1, 2, it's going to be negative 1 squared plus 11 all over 2 plus 1 squared. This is going to give us negative 12 ninths, or negative 4/3. All right, so now we're ready to find the tangent plane. So I'll go red for this one. We'll go back up to the top here. The tangent plane So we're going to use our formula, which is z equals f sub x1, or f of x1, y1, plus f sub x of x1, y1 times x minus x1, plus f sub y of x1, y1 times y minus y1. So there's our formula, and we're just going to rewrite this for our values, plugging in our point 1, 2, 3. So this is going to look like f of 1, 2 plus f sub x of 1, 2 times x minus 1 plus f sub y of 1, 2 times y minus 2. And we already know those values of f of 1, 2, f sub x of 1, 2, and f sub y of 1, 2, because we just calculated them down here. So we're just going to plug them in. We're going to get z equals 3 minus 5/3 x minus 1 minus 4/3 y minus 2. And then after some distribution, and I'm also going to rewrite this 3 as 9/3, just because that will come in handy later. After some distribution, there's going to be negative 5/3 x minus 5, or plus 5/3 minus 4/3 y plus 8/3. And after collecting like terms, we're going to have negative 5/3 x minus 4/3 y plus 22/3. And so to rearrange this just a little bit, we're going to subtract over our x and y terms here, and our constant there. We're going to get 5/3 x plus 4/3 y plus z minus 22/3 equals 0. And there is our tangent plane equation. But the book is going to simplify it additionally, so it's going to multiply this whole quantity times 3. And that looks like 5x plus 4y plus 3z minus 22 equals 0. And there is our final answer, our tangent plane equation to the given surface at point P 1, 2, 3.